Okay, so welcome back to my maths homework. Let's do some questions now. So the first question says, the first part of the first question says, the summation from r equals to 1 to n of 2r plus 3. So that is the same as saying 2 times the summation from 1 to 1 to n of r plus the summation from 1 to n of 3. Okay, that's going to be 2 times, well, this summation, it's going to be n into n plus 1 upon 2. Okay, that's just like 1 plus 2 plus 3 plus all the way till n, you get n plus 1 into n upon 2. Very correct. And then over here you have 3 times n, so you have 3n. Okay, this cancels, you got n squared plus n plus 3n, so that's going to be 4n. That's it, that is it. Let's go to the next question. So you have summation from r equals to 1 to n of r plus 2 into 3r plus 1. First of all, let's just expand this. That is the same as saying summation from 1 to n of, you got 3r squared plus let's see, r plus 6r, that's going to be 7r plus, I think, yes, that's correct. So you got 6r plus 7. Okay, fine. And then you got 2, so that's going to be, you got 3. And then summation of r squared from 1 to n, that is going to be this thing, n into n plus 1 into 2n plus 1 upon 6, plus you got 7 times the summation of r from 1 to n, that's supposed to be n into n plus 1 upon 2. And then you got 2 summation from 1 to n, that's going to be 2n. Okay, now let's expand this. So let's first of all try to simplify it out. So that is the same thing as saying this cancels, so you got 2 over there, so it's going to be equal to, you got n. Okay, first of all, you just take one n common from each of them, so it's going to be n into n plus 1 into 2n plus 1 upon 2. You know what, let's just take n by 2 common, that will be better. So n plus 1 into 2n plus 1, that is supposed to be 2n squared plus, you got 2n plus n, that is 3n plus 1. Okay, and then over here you got n by 2, that's out, so you got 7 into n plus 1, that's supposed to be 7n plus 7. Now over here you got n by 2 out, so you got plus 4. Okay, that's supposed to be n by 2 of 2n squared plus 3n plus 7 is plus 10n. 7 plus 1 is 8 plus that's supposed to be 12, which is n into, you got n squared plus 5n plus 6, which can also be written as n into n plus 2 into n plus 3. Okay, that's nice. Let's move on to the next question. Just delete this. Okay, so the next question is summation from r equals to 1 to n of r into r plus 1 into r plus 3. Not a big deal, let's just do this. So it's supposed to be summation from 1 to n of, let's expand this. So r into r plus 1 into r plus 3, that's supposed to be r squared plus 4r plus 3, which is summation from 1 to n of r cubed plus 4r squared plus 3r, which is, okay, summation of r cubed from 1 to n, that is n in n squared actually into n plus 1 squared upon 4. Okay, and then you got plus 4 times the summation of r squared, that is n into n plus 1 into 2n plus 1 upon 6. And now that we have been using this formula for so long, I will actually provide a proof of that formula in one of my videos. So yeah, I promise that. Okay, and the summation of 3r, so you got 3 times the summation of r, that's supposed to be 3 into r into r, n into n plus 1 upon 2. Okay, let's take some stuff common. First of all, you got n and n plus 1, so let's take that common, n into n plus 1. And then, okay, let's see what we can do. You got 2n upon 3 over there. Maybe we should take 12 common. Yes, let's take 12 common. Okay, so over here you will have 3n, wait, what? You will have 3n into n plus 1. Okay, and then you got 12 in the denominator. First of all, it was supposed to be 3, then you got 4 times 2 is 8, so 8. This n into n plus 1 is gone, so you got 2n plus 1 only. And then over here this complete term is gone. Okay, and then you got 12 in the denominator, so it should be plus 18. Okay, that's simplify this, n into n plus 1 upon 12 into, this is supposed to be 3n squared plus 3n plus 16n plus 8 plus 18. Okay, fine. So that's supposed to be n into n plus 1 upon 12 of 3n squared, 3n plus 16n, that is 19n, plus 8 plus 18 is 26. Is this somehow factorizable? Well, even if it is, we don't care, because that's it, that's the solution. Okay, let's move on to the next question. The next question is the fourth one. Okay, wait a second. Oh yes, so the next question is, wait, what? Oh, okay, so it is summation from r equals to 1 to n of 6r squared minus 2r plus 5. Okay, so just doing it directly. So we got 6r squared, that's supposed to be n into n plus 1 into 2n plus 1 upon 6. So upon 6, and this cancels, you got minus 2r, so minus of minus 2 times r, you got n into n plus 1 upon 2, so that's supposed to be minus n into n plus 1. And then you got plus 5, so plus 5n. Easy. Just take an n common, so you got n plus 1 into 2n plus 1. Okay, but first of all you need to take care of this thing as well. So like, yes, so you got n plus 1 into 2n plus 1. You got this n cancelled out, you got minus of n plus 1, and then you got 5n, sorry, just 5, not 5n, that is going to be equal to n, and then you got n plus 1 common, so you got 2n plus 1 minus 1, that is supposed to be 2n plus 5, which is n into 2n squared plus 2n plus 5. Yes, not factorizable, I think. Whatever, it's going to leave it like that. So the next question is summation from r equals to 1 to 10. Oh, now we have a finite value and not just some generalization, but I think we should better do the generalization as well, so that we will get to understand what it really is. So let's do this thing first. R summation from 1 to n, r equals to 1 to n of 4r minus 3 squared. Okay, so that's supposed to be 16r squared. 4 times 3 is 12 times 2, which is 24 r plus 9. Okay, 16 times, so over here we will have r squared, so got n into n plus 1 into 2n plus 1 upon 6. So this is supposed to be 8 and 3. Then you will have minus 24r, that is my, okay, minus 24. Minus 24 times the summation of r from 1 to n, that is n into n plus 1 upon 2. So this is supposed to be 12 over there, and then you got 9n. So let's take something common. You got n by 3 common, so you will have n plus 1 into 2n plus 1, actually 8 times of that thing. Okay, and then you got minus 12 times 3 is minus 36 into n into, oh, so that n is gone, so minus 36 of n plus 1 plus 9 times 3 is 27, right? Okay, that is going to be some expansion. So n by 3 of, what is this thing, 8 times n plus 1 into 2n plus 1. Okay, that looks not nice, right? But we have to do this, so yeah, let's do this now. So 8 times of 2n squared plus got 2n plus n is 3n plus 1 minus 36n minus 36 plus 27, so that's supposed to be minus of yes, minus of 9, I think. Yes, so 16 minus 9 is, yes, minus 9. Okay, so now first of all we need to simplify this further. So this is supposed to be equal to n by 3 of yes, 16n squared plus 8 times 8 is 24n minus 36n. Got 8 minus 9 is minus 1. And by 3 of 16n squared, this is supposed to be minus of what, minus 12, minus 12 and minus 1. Is this factorizable? So So 16 times minus 1 is minus 16, which is minus of 8. Yes, it is. So like minus 4 no wait, no, minus 8 times 2 won't work. You want 12, right? 12 can be, wait, how do we factorize this thing? That is not nice. Just hope we did everything correctly. Yeah, it should have gone like that. So you got 4n squared, something like that. That's 1. Okay, just going to leave it there, maybe. Or maybe we did something wrong. So you got r squared, which is definitely this thing. That's supposed to be 8 times n into n plus 1 into n plus 1 upon 3 minus of this guy plus 9n. Yes, so that is correct. So yeah, it would work something like this. I'm not going into further detail on how to factorize this. It is factorizable, but I don't think we should factorize it. So yes, let's just deal with this thing first. So this is supposed to be this summation from 1 to n. So now let's put n equals to 10 over there. So summation from 1 to 10 of this thing, that is supposed to be equal to, so if we put 10 over there, you got 10 into 11 into 21. Okay, so 10 into 11 into 21 into 8 upon 3 minus 12 into 10 into 11 and then plus 90. Okay, so let's see what happens. This is 7. Yes, and then you got this 10 into 11 common, so you got 7 times 8 is 56. 56 minus 12, right? So 10 into 11 times, what is this? 56 minus 12, that is 44. Yes, so into 44 plus 90, which is, yes, everything is correct, no problem. Yeah, there should be no problem, which is supposed to be equal to, okay, so you got this thing. Well, 11 times 44 is 484 plus 9, that is supposed to be 493. So 4930, I think. Yes, so yeah, that's the answer. So this is supposed to be equal to 4930. Okay, so the next question is summation from 1 to 20. Okay, summation from 1 to 20 of r of 2r plus 1. Okay, once again the same idea. We're just going to use this thing first. So like, let's first of all find out this thing, summation from 1 to n of r into 2r plus 1. That is you got 2r squared. It's like this thing is supposed to be 2r squared plus r. Okay, so 2 times of r squared, you want n squared into n, no wait, square, right, not cube. So 2 times of n into n plus 1 into 2n plus 1 upon 6 plus, you got r, so that's supposed to be n into n plus 1 upon 2. Nice. So this is supposed to be 3, should have n into n plus 1 upon 6, right? So you got 4n plus 2 plus 3. So yeah, just n into n plus 1 into 4n plus 5 upon 6. Okay, so now let's put n equals to 20 in this. So summation from 1 to 20. 1 to 20. What is this thing? So yeah, so summation from 1 to 20, that's supposed to be equal to, if we put 20 in that, so 20 into 21 into 85. Yes, 85 upon 6. So this is supposed to be, right, this is 10, this is 3, this is 7, so 70 into 85, so 35 and 56, which is 590, 5950. Okay, yes, that should be correct. So you got 5950. Okay, so the next question is find the sum to n terms of the series whose rth term is. Okay, fine. So the rth term of the first one is given by 1 plus 2 plus 3 all the way till r upon r. Okay, no problem. Well, this thing, it can be written as r into r plus 1 upon 2 upon r. Yes, so this is supposed to be equal to r plus 1 upon 2. Now if we sum this from r equals to 1 to n, right, r plus 1 upon 2, that is supposed to be equal to half of the summation from 1 to n of r, that is n into n plus 1 upon 2, plus summation of 1 from 1 to n, that is just n. So n by 4 of n plus 1 plus 2, that is n plus 3. That's it. Like, that was very easy. Fine. The next thing is 1 squared plus 2 squared plus 3 squared all the way till r squared upon r into r plus 1. Okay, that's also very easy. So just do it yourself. This is going to be 2r plus 1, right, r into r plus 1 into 2r plus 1 upon 6. So 2r plus 1 upon 6, because these things will cancel out the upper part, I mean r into r plus 1 part. And then we sum this from r equals to 1 to n. Okay, so that's supposed to be 1/6 of 2 times, so you got r, that's supposed to be equal to n into n plus 1. Wait, why is this happening? So you got n into n plus 1 upon 2. Okay, this cancels, and you got 1 from 1 to n, that's supposed to be equal to n. So this is n by 6 of n plus 2. Very easy. Okay, so the next thing is 1 cubed plus 2 cubed plus 3 cubed all the way till r cubed upon r squared. Okay, that's also not a big deal. So it's just going to be r squared into r plus 1 squared upon 4. But now you also have this upon 4r squared, so this cancels. So if we sum this from r equals to 1 to n, this is supposed to be, oh, you know what, I'm not going to go the usual traditional way of expanding this and then doing all that stuff. No, I'm going to do this with a little more creativity. So this can be written as 1/4 summation from r equals to 1 to n of r plus 1 squared. What is that thing? That is just 1 plus 1 squared, which is 2 squared plus 3 squared plus 4 squared all the way till n plus 1 squared. Now if I add 1 to that and subtract 1 to this, you get a new thing. You get the summation from r equals to 1 to n plus 1 of r squared. We know what that thing is supposed to be. That thing is supposed to be, if you put this thing, right, so you got it's supposed to be equal to n into n plus 1 into 2n plus 1 upon 6, but instead of n we will have n plus 1 over here. So you will have n plus 1 into n plus 1 plus 1, which is n plus 2, and then 2 times of n plus 1 is 2n plus 2, and then that plus 1, so 2n plus 3. All right, that thing upon what? Upon 6. Yes, minus 1. Not a big deal at all. So yes, you can obviously expand this and then see what this turns out to be, but I'm not going to do all that stuff. So you're just going to leave it like that, or maybe I should in fact expand this. I mean, how bad can it go? So yeah, let's expand this. It's supposed to be 1/4 of, yeah, it's supposed to be n plus 1 into, you got 2n plus 3. Okay, so 2n squared, and then you got 4n plus 3n is 7n plus 6, this thing upon 6 minus 1. Okay, so you got 1/4 of this plus that, supposed to be 2n cubed, and then you got 7n squared plus 2n squared is 9n squared, plus 6n plus 7n, that's supposed to be 6n plus 7n is 13n. Okay, and then you got plus 6 over there. No problem. I think we covered it up. Yeah, that should be correct. So we got 7n squared plus 2n squared is 9n squared, then you got 6n plus 7n is 13n plus 6. Fine. And then minus 6 upon 6. So this cancels. So now whatever this thing factorizes to, it's supposed to be like n by 24 of 2n squared plus 9n plus 13. Yeah, we can just factorize that thing. So no, actually not. Fine, just going to leave it like that. Let's move on to the next question. So the next question is, oh, that looks amazing. So you got 1 cubed plus 2 cubed plus 3 cubed all the way till r cubed upon 1 plus 2 plus 3 all the way till r. Fine. So this thing, it can be written as n squared into n plus 1 squared upon 4 divided by n into n plus 1 upon 2, which turns out to be n into n plus 1 upon 2. Sorry, r into r plus 1. It's like pi. So it's supposed to be till r cubed, so it's going to be r into r plus 1 upon 2. So that turns out to be half of r squared plus r. So if we sum this thing, r into r plus 1 upon 2 from r equals to 1 to n, this thing is going to be half of, so you got r squared. For that we will have n into n plus 1 into 2n plus 1 upon 6, yes, and then plus r, so that's supposed to be n into n plus 1 upon 2, no problem. So that's supposed to be n into n plus 1. Let's see, so you got, maybe you should take 12 common. Okay, fine. So yeah, I just took 6 common from that, so it's going to be upon 12, and then you got 2n plus 1 plus 3 times of whatever is remaining, which is just 1. So you got this thing, turns out to be 2n plus 4. This is getting back, so you got n plus 2 over there. Yeah, whatever, very easy, not a challenge at all. So the next question, let's move on to the next question now. So the next question is, find the sum to n terms of the following series. So first of all, you have 1.3 plus 3.5 plus 5.7 and keeps going like that, so it's like an infinite series. No, wait, sum to n terms. Okay, sum to n terms of the following series, so it keeps on going till n terms. Fine. 1.3 plus 3.5 plus 5.7. What is this? Is there some kind of difference common? So this is 3.5 minus 1.3 is 2.2. This is also 2.2. Yeah, okay, so it's an arithmetic series, no problem. Right, it's just an arithmetic series with the difference being 2.2, the first term being 1.3, and we want to find n terms, right? The sum till n terms of this thing. That's not a challenge at all. So you just get n by 2 of 2a, which is this thing, like 2.6 plus n minus 1 of d, which I'm going to write it as 2.2n minus 2.2. It's going to be n by 2 of 0.4 plus 2.2n, which is nothing but, you got 1.1. What's this thing? It's not 11. So you got 1.1 n squared and then plus 0.2n, like that. Easy. Yeah, so the next question is 3.1 plus 5.8 plus 7.15. This is another no, wait, 7.15, huh? 3.1 plus 5.8. What's going on with this thing? What's the difference? So over there it was obviously an arithmetic series, but over here it's okay, maybe it's a geometric series, I don't know. So 58 upon 31 is supposed to be equal to 715 upon 58. Doesn't look like that. It's definitely not like a geometric series. What about the arithmetic or geometric series? So wait a second, what's this thing? Oh no, this is not supposed to be point. It's supposed to be a multiplication. Oh shit. So this was actually 1 into 3 plus 3 into 5 plus 5. Okay, that makes sense. Right. Why did this happen to me? Fine. So this is the summation from r equals to 1 to n of, for the first term you got r, and then you got r plus 2. So what's that supposed to be? That's supposed to be r squared plus 2r, right? So for r squared, you will just have n into n plus 1 upon, n plus 1 into 2n plus 1 upon 6, and then you got 2r, that's supposed to be n into n plus 1 upon 2 into 2, so that cancels. Yes, It's supposed to be n into n plus 1 upon 6. We get that common, and we got 2n plus 1 plus 6, which is 2n plus 7. That's it, like that. So yeah, it's supposed to be 1 into 3 plus 3 into 5, but fine, man. Okay, so the next one is 3 into 1 plus 5 into 8 plus 7 into 15. Yeah, something like 1 into 3 plus 5 into 8 plus 7 into 15. Right, so you got 1 to 5 a jump of 2, 5 to 7 a jump of 2, then you got 3 to 8 a jump of 5, but 15, wait, 15, that is weird. So 15 is not like having a jump of 5. Something is not correct. What's the deal? Why did they put 15 over there? 187. No, it's not working. 7. Wait, 187. Oh yeah, sorry about that. So it was really like that. So got 3 into 1 plus, so 3 to 5 you got a jump of 2, 5 to 7 you got a jump of 2, 1 into 8 you got a jump of 7, and 8 to 7 you got a jump of 7. So yes, it is summation from r equals to 1 to n of, it's supposed to be equal to r plus 2. Wait, no. So what's the general term of this thing? 3, 5, 7 stuff. So the first term is a, then the difference is 2, so you got 3 plus r minus 1 of 2, that's supposed to be equal to 2r plus 1. So you got 2r plus 1 into the next thing is 1 to 8, it's like 1 plus, the difference is 7, so r minus 1 of 7, supposed to be 7r minus 6. Okay, 7r minus 6, right. So I don't really want to do this because it's just getting repetitive now. Yes, just going to be a big trinomial, just have to go through all the steps and then factorize this and stuff. I don't want to do this, just leave it like that. Okay, so the next thing is 2 squared plus 4 squared plus 6 squared. Oh, that's not really nice. So just like 4 times of 1 squared plus 2 squared plus 3 squared plus 3 squared, and then you have like n terms, right? So it's supposed to be n squared. Easy, not a big deal at all. It's supposed to be n into n plus 1 into 2n plus 1 upon 6, but 4 times of that, so 2 times of n into n plus 1, 2n plus 1 upon 3. Easy, not a big deal. Okay, the next thing is 1 into 2 into 3. Oh, that looks interesting. 1 into 2 into 3 plus 2 into 3 into 5 plus 3 into 4 into 7. Alright, so yeah, you got 2, 3, 4, 3, 5, 7. So the first series is that you have 1, 2, 3, that's just r itself, so you got r. Then you got 2, 3, 4, that's just r plus 1, no big deal. You got 3, 5, 7. So 3, 5, 7 stuff. That's supposed to be equal to 2r plus 1, right? Why does this look so much familiar? Yes, okay, I know. So it's like the summation of squares, right? It's like sum of, okay, fine, move on. So just have to sum this thing from r equals to 1 to n. Kind of boring actually. It's like 1 to n of, so you got 2r squared plus 2r plus r is 3r. Have we done this kind of thing beforehand? I don't think so. Okay, and then you got 2r cubed plus 3r squared plus 1. Boring. So for r you just have n squared into n plus 1 squared upon 2 plus 3r squared supposed to be equal to r, I mean n into n plus 1 into 2n plus 1 upon 6, but then you got upon 2 plus n, right? Supposed to be equal to n by 2 common, you got n into n plus 1. Yes, this is supposed to be equal to, wait, n into n plus 1 squared. Okay, fine. So n into n plus 1 squared plus n plus 1 into 2n plus 1. Okay, It's just getting frustratingly big. Okay, fine. Oh, it's supposed to be equal to r. Why? N plus 1 upon 2. Fine. So you got that n by 2 common, and you got n plus 1 over here. I could have also took some more stuff common. So you got n plus 1 common. So you will have n into n plus 1, just n squared plus n plus that thing is gone. So you just got 2n plus 1 plus 1. So you got 2n plus 2, which is n by 2 of n plus 1 into, you got n over here, and then you got 2 over here, so n plus 2. So, and what about this thing? This gets over here, got squared. Easy, not a big deal. Now all that is just tiresome and like very long to do. So you got 5 squared plus 8 squared plus 11 squared. Can't believe it. So 5 to 8 you got a difference of 3, 8 to 3 got a difference of 3. So it's just like 5 plus r minus 1 into 3, that thing squared, supposed to be equal to, you got 3r plus 2, so 3r plus 2 squared, which is 9r squared plus 6 times 2 is 12, 12r plus 4. And when you sum this from 1 to n, you get 9 times. For r you have n into n plus 1 into 2n plus 1 upon 6. Okay, for this thing 12r, you just have 12 into, yes, n into n plus 1 upon 2. For 4 you have 4n, right? So this thing is supposed to be 3 cancelled. Over here you got 2, over here just going to leave it like this, going to write it as 8 by 2n. Fine, it's supposed to be equal to n by 2 of so got n plus 1 into 2n plus 1, which is 2n squared plus, what's this thing, 2n squared plus 3n, I guess. It's like 2n and then n. Fine, it's like plus 1. Yes, but wait a second, it's supposed to be 3 times of that stuff. So it's supposed to be equal to 6n squared plus 9n plus 3. Then you got 12 times of n into n plus 1. Why, this is getting very boring. Oh, it's got n away, so we got 12n plus 12 plus 8. So whatever that turns out to be, fine. Move on to the next question, just delete it like that. Okay, fine. So the next question is 1 into n plus 2 into n minus 1 plus 3 into n minus 2 keeps on going. Oh, come on. Fine, it looks interesting, but it's not that interesting. In fact, it's just a summation from r equals to 1 to n of r into, so you got, yes, like n minus r minus 1. Yeah, I think n plus 1 minus r. Fine. So when r equals to 1, this is n. When r equals to 2, this is n minus 1. Fine. Just take n as a constant for this summation thing, and then we will be done. So it's just supposed to be summation from r equals to 1 to n of n times r minus r squared plus r. No big deal. Actually, I should say n plus 1 times r, whatever. So it's supposed to be n plus 1, then summation of r, that is n into n plus 1 upon 2, minus summation of r square, that is n into n plus 1 into 2n plus 1 upon 6, right? So what do we do with that? Just take this thing common. So you got n into n plus 1 upon 2 common. You got n plus 1. Okay, actually I should say 6 commons, like 3n plus 3. Fine. And then you got minus 2n plus 1, so minus 2n minus 1. Yeah, it looks like that. So it's supposed to be equal to n into n plus 1 upon 6. And then you got 1n and, oh, so it's n plus 2 upon 6. Fine. Okay, let's move on to the next question, which is find some n terms of the following series. Oh, come on. 1 plus 1 plus 2 plus 1 plus 2 plus 3. Hey, wait a second, I think we have done this kind of a question once, right? So what is this thing? It's just like r into r plus 1 upon 2 summation from r equals to 1 to n, right? Every term is nothing but summation of first r natural numbers, which is r into r plus 1 upon 2, right? So this thing is like half summation of, you got r squared, so n into n plus 1 into n to n plus 1 upon 6, and then you got plus r, which is n into n plus 1 upon 2. That is supposed to be equal to half, and then you got n into n plus, I think I should say 1 by 12, so you got n into n plus 1, and then the remaining stuff. So you got this 6, okay, so you got 2n plus 1, and then it's supposed to be 3 times the remaining stuff, so just that thing itself. So you got n into n plus 1, 2n plus 4 is just n plus 2 into 2, so this is upon 6. Easy. Okay, and in fact I have a nice generalization for this thing, that if you keep iterating this in like what should I say, so you got 1 plus 1 plus 2 plus 1 plus 3, 1 plus 2 plus 3, this thing turns out to be that thing, right? So what about this thing, 1 plus 2 plus 1 plus 2 plus 3 all the way, then you got plus 1 plus 2 plus 1 plus 2 plus 3, keeps going like that. It's plus, okay, so that thing that turns out to be n into n plus 1 into n plus 2 into n plus 3 upon some constant. I don't remember that constant exactly. I think it was, well, 6 is like 3 factorial, so that could have been 4 factorial, I don't know. But there is a nice generalization of that thing as well, which I did as a kid. Yes, I did as a kid because I got bored. Move on to the next question. So you got 1 squared upon 1 plus 1 squared plus 2 squared upon 2. Okay, so boring. Just so summation from, okay, so you got, what is this thing, so you got sum of squares of the first r natural numbers is supposed to be equal to r into r plus 1 into 2r plus 1 upon 6, but that divided by r, so this cancels. So now if we sum this from r equals to 1 to n, this is like summation 1/6 the summation of from r equals to 1 to n, and then you got 2r squared plus 3r plus 1. Yeah, just boring. So I think I don't want to do this now. Just leave it. Okay, this is getting very seriously repetitive. Okay, so the next question is, wait, isn't this the, okay, fine, it's like a little change over there. So it's nothing but the summation of first r squares upon the summation of first r natural numbers. Fine. So yes, it's just r into r plus 1 to 2r plus 1 upon 6 divided by r into r plus 1 upon 2, like that. So this cancels, you got upon 3 over there. Summation from r equals to 1 to n, so 1/3, then you got 2r, so 2 into n, I think, yes, so 2 into n plus 1 upon 2, right? Then got from 1 to n of, like, yeah, from 1 to n of summation of 1, that is just n itself, so like this cancels, so n by 3 of n plus 2, like that. Okay, the next thing is find the following sums. Man, this is repetitive. Okay, 1 cube plus 2 cube plus 3 cube all the way till 20 cubed. Really. So yeah, so we know that the summation from r equals to 1 to n of r cubed, that is supposed to be equal to n squared into n plus 1 squared upon 4. So now if we put the value of n as 20, just get 20 squared into 21 squared. What's happening? Okay, the 21 squared upon 4, fine. Well, this is like, okay, got 100 upon 4 cancels, 21 squared, which is like 400 plus 2 into 1's 20 is like, fine, 40 plus 1 is like 441. Yes, that's it. It's like 44100, some crazy number. Okay, the next thing is 8 squared plus 9 squared plus 10 squared plus 22. Oh, that's actually nice. So this thing can be written as 22 squared plus 21 squared all the way till 1 squared minus 7 squared plus 6 squared all the way till 1 squared. So yeah, that's actually nice. So that thing is supposed to be, so first of all, you got this thing is supposed to be 22 into 22 plus 1 is 23, and then you got 23, okay, 22 double, this is 44 plus 1 is 45, that thing upon 6 minus okay, so you got 7 plus, okay, you got 7 plus 1 is 8, 7 double is 14 plus 1 is 15 upon 6, right? So let's see what cancels out. So you got 11 and 3, supposed to be 15. So 11 into 23 into 15 minus what's this thing? So you got 5 and 2, and you got 4, minus 7 into 4 into 5. Oh, the only common thing is a 5. Fine. So 3 into 23 is what's this thing? 69 into 11 minus 7 into 4 is 28. Okay, 5 into 69 into 11 is supposed to be equal to 69, which is 759. Okay, 759 minus 28, which is 5 times of, you got 731. So 5 into 731, which is, what's that? 5 into 731 is, you got 35. 5, you got 5 1 carried on. 35 plus 1 is like 36. 3655. So yeah, that's the thing. The next thing is 40 cubed minus 38 cubed plus 36 cubed plus minus 34 cubed. Okay, fine. So that's also not a big deal. I can just regroup this. Yes, I think. So you got 38 cubed, 34 cubed, or maybe not. Okay, so here's the thing. R cubed, actually I should say R plus 2 cubed. Fine. So like this goes all the way till, hey, first of all, we can notice that all of these are just even numbers. So maybe we can factorize, we can factor out an 8 from this, right? So if we factor out an 8 from this, it's going to be 20 cubed minus 19 cubed plus 18 cubed minus 17 cubed, and it keeps going like that till you have 2 cubed minus 1 cubed. Wait a second. Oh, that's nice. This is not a big deal. It's like 8 times. First of all, I'm just going to regroup this. Is 20 cubed plus 18 cubed till 2 cubed, then minus 19 cubed plus 17 cubed. Wait, no, don't do that. Don't do that yet. We can do better than this. So what's this thing? It's just yeah, fine. It's like 20 cubed minus 19 cubed plus 18 cubed minus 17 cubed. Alright, this is R plus 1 cubed. What's the general form of this thing? You got 1, then you got 3, then you got 5, 7, it's like 2R minus 1. So these are 2R minus 1, and then that thing plus 1 is supposed to be 2R. So you got 2R cubed minus of 2R minus 1 cubed. That's the general form of every term like this, right? Till we have this thing. I mean this thing. Okay, and then, oh wow, this is really sick. Fine. Oh, it's like -1 to that thing. Wow, it's not expecting that thing. Okay. Yeah, we can be more creative, or we can just go like this thing. Yeah, so this goes from R equals to 1 till you have this 2R being equal to 20. So you got 8 summation from R equals to 1 to what? To 10. Okay, of 2R cubed minus 2R minus 1 cubed, right? We can do that easily. Just going to be a trinomial, a quadratic expression, and then yeah, just doable, right? So 8 times the summation from R equals to 1 to 10 of, if you use the difference of cube, so you just have 1 times the square of this guy is supposed to be 8R squared plus the square of this guy, that is supposed to be equal to, oh wow, I just won't want to do this now. Wait, 4R squared, sorry, 4R squared plus 4R squared minus 4R plus 1, and then you got plus the product of these two is supposed to be equal to 4R squared minus 4R, or minus 2R actually. Yes, now I just don't want to do this now. This is getting very repetitive, very tedious. We could be more creative, but yeah, whatever, just move on. It's not a big question, so yeah. So the next question is, find the following sums. Yeah, we have been doing that the whole time. So 2 squared minus 1 squared plus 4 squared minus 3 squared plus 6 squared minus 5 squared plus you got n brackets, right? So just find the general term of each of them, right? Yes. So here's yes, like first of all, 2 squared minus 1 squared, that's the same thing as 2 minus 1 into 2 plus 1. So this thing just turns out to be 1. You got 2 plus 1, okay, then plus you got 4 squared minus 3 squared. Well, that thing is just 4 minus 3 into 4 plus 3, so you got 4 plus 3 because 4 minus 3 is 1. Similarly, you got 6 plus 5 plus the next thing, and keeps going like that till you have n brackets. Yes, fine. So n brackets, and each of these brackets contain two terms, so there are going to be 2n of these terms. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 till 2n of these things, right? I mean 2n of numbers. So that's going to be, yes, the sum of first 2n natural numbers, like that. So yeah, it's supposed to be n, which is 2n, into n plus 1, which is 2n plus 1 upon 2. This cancels. We got 2n squared plus n. Easy. This was nice. So the next thing is 3 cubed minus 1 cubed. Okay, why? So fine, 3 cubed minus 1 cubed plus 7 cubed minus 5 cubed. Okay, fine. So what's happening? First of all, you got this is 1 plus 1 and then 5 and then 9. Right, so 3 to 7 jump of 4, 7 to 4, 7 to 11, that's a jump of 4, 1 to 5 jump of 4, and then fine. So what's this supposed to be? You got 1, then you got 5, then you got 9, keeps going like that. This is 2r, wait, no, not 2r, this is 4r plus 1, no wait, 4r minus 1 plus 1 is supposed to be 4r minus 3, right? So this is 4r minus 3. So you got this thing 4r minus 3 but plus 2, so minus 1 cubed minus 4r minus 1 cubed. Okay, that's the general term of this series till you have n brackets. So till you, it's supposed to be summation from r equals to 1 to n. Yes, I don't want to do this. Okay, it's supposed to be 4 minus 3. I don't want to do this at all, right? But now I know I can do this if I ever get this in exam. Yeah, let's move on to the next question. So 1.2 plus, I mean 1 into 2, not making that mistake again. Don't want this now. Delete this. Okay, so you got 1 into 2 plus 2 into 3 plus 3 into 4 till n terms upon 1 plus 2 plus 3 plus 4 up to n terms. Okay, that's supposed to be equal to 6, then find n. Okay, that's a nice question. I just do this. I mean, it looks nice. So you got summation from r equals to 1 to n. You got n terms, right? So it's supposed to be r into r plus 1 upon this thing till n terms is n into n plus 1 upon 2. What a deal. What about this thing? So r squared plus r, that is supposed to be n into n plus 1 into 2n plus 1 upon 6 plus r. So you have n into n plus 1 upon 2, which is n into n plus 1 upon 6 into 2n plus 1 plus 3 is 2n plus 4. Wait a second. Yes, correct. So 2n plus 4. It's like n into n plus 1 into 2n. Also I got n plus 2 upon 3. Okay, fine. So what's this thing? This thing turns out to be n into n plus 1 into n plus 2 upon 3. Yes, looks correct. I mean, yeah, nothing could go wrong. Yeah, upon 3, and then this divided by n into n plus 1 upon 2. This cancels, just got 2/3 of n plus 2 everywhere. So yeah, that's it. Like this is equal to 200 upon 197, something like that. So this is 100, 197's we're getting 15, and then you got 47. Wait, no, got 18 first, like 16. I mean 6. You got 18, then you got 17. Wait, what? Doesn't make sense. Fine, so like n plus 2 upon 3 equals to 100 upon Is this really 197? 197. Wait a second. It's like 70 days. 197. That's a very um, not nice number. Yeah, it's like n plus 2 upon 3. Could it have been possible that we made some kind of mistake once again? No, I don't think so. Well, n cannot be an integer in that case. Oh, sorry. This thing is supposed to. Oh, sorry. So this is a different sum and this is a different problem. So you got equal to 6, right? I'm really sorry about that. So this is supposed to be equal to 6. So you got 3 over there. You got n plus 2 equals to 3 into 3 is 9. So n equals to 7. Find n equals to 7. Okay. And the next thing is, so you got the same series just like before, so it's supposed to be equal to this thing, but then you got 1 square plus 2 square till n, okay, till n terms. So just delete some other stuff. First of all, just delete this, delete that as well. Okay, so you got this thing, right? N into n plus 1 upon 2n plus 1, I mean into 2n plus 1. Wait a second. What was that thing? Oh yeah, n into n plus 1 into n plus 2 upon 3, right? N into n plus 1 into n plus 2 upon 3. That was the sum which we got before. So n into n plus 1 into n plus 2 upon 3. This is the sum of this thing. And then upon 1 square plus 2 square, 3 square till n terms is supposed to be equal to n square. Wait, squares, right? So yes, n into n plus 1 into 2n plus 1 upon 6. You got upon 2, so like this goes on the top. You got this thing cancels. So you got 2n plus 4 upon 2n plus 1 is equal to 200 upon 197. No big deal. Yes, tables. You got n plus 2 upon 2n plus 1 equals to 100 upon 197. Okay, so from that we can say, now you just need to do this, right? It's like 197 and plus, what's 197 times 2 is 38 and 14, so 394. So you got 197 and plus 38 and 14, which is 394, equals to 200n. Oh, plus 100. That gives me 3n, okay, equals to 294. So n equals, you got 27, so 9, and then you got 24, 8, 98. Find n is 98. Yeah, that's it. That was my homework. I mean, one part of my homework. Still a lot of my homework is just remaining. I have to make a lot of videos about that. So yeah, I'll see you in the next video.